So hello friend, this is Kaustup Patar again with a new video. Welcome to our channel Making Maths Easy. Today in this video we are going to solve some trigonometric function and we are going to find the derivative of the trigonometric function. In the last video I have found the derivative of some algebraic expression. So today we will be going to find the derivative of some trigonometric function. So let's start. So the first sum is differentiate with respect to x, which is equal to sine of x square plus x, sine of x square plus x. So let us consider as y equal to sine of let us consider y equal to sine of x square plus x. Okay. So y is equal to sine of x square plus x. No, so now we will differentiate. So dy by dx, dy by d of x will be equal to d upon d of x of d upon d of x of sine x square plus x. So we know the differentiation of sine theta or the derivative of sine theta. So the derivative of sine theta will be equal to cos theta. So I will write here as a cos theta and x square plus x, and then again we will differentiate a loop differentiation. I told you in the previous video, if we are differentiating any number, so we have to go on deep inside that number on differentiating. Suppose we are differentiating sine theta, so first we have to differentiate sine, then we have to differentiate theta. First, if I am differentiating any number with the help of power, so first I have to differentiate the power and then I have to differentiate that particular variable or number. So this will be d upon d of x into the differentiation of x square plus x. So this will be differentiate again, and I will write here as, so my final answer will be cos of x square plus x into the differentiation of the derivative of the differentiation of x square is equal to 2x, and the derivative or differentiation of x is equal to 1. So it will be 2x plus 1 into or into cos of x square plus x, or cos of x square plus x into 2x plus 1. So this is our first answer. We have solved it. So let's move to the second sum. Second sum is sine square of x upon 1 plus cos square of x. So let's solve it. So for second sum, let us consider as let us consider the value of y equal to this value. So my dy by dx, the derivative of the function will be equal to dy divided by d of x will be equal to d upon d of x of d upon d of x of d upon d of x of this particular function. So we will differentiate right now. In this case it is little bit different. This rule I have not told you uh, in the previous videos, so I will tell you the differentiation. Let's come to the rule. The rule of uv, this is called a rule of uv. In order to differentiate the rule of uv, we need two terms, or we can say the differentiation of u divided by v. So there are two rules. First rule I will tell you, d upon d of x into u divided by v. So it will be u upon, first we will solve u upon v, because the sum is based on u upon v. so it will be u upon v. Our rule is u upon v. So for solving this, we need a divide operator, and then we will solve this sum. So it will be v into derivative of u, v into derivative of u minus minus uh, v minus u into derivative of v divided by v square, So this is a standard formula of derivative of u divided by v for division. So for multiplication, I will tell you in the when we are going to solve sums based on multiplication. So let's solve the sum based on division. So what we have here as division of uv, we can say, so u divided by v. So this can be considered as u, this can be considered as u, and the denominator part can be considered as v. This denominator part can be considered as v, and this can be considered as u. So for that we need differential equation, as so our differential equation will become d upon d of x of u by v. So it will be differentiation of 1 plus 1 plus cos square x into the derivative of d upon dx of sin square x. So minus sin square x into the derivative of d upon d of x of 1 plus cos square x. So according to the rule, we have put the values divided by 1 plus cos square x the whole square, 1 plus cos square x the whole square. So we have put the values in the formula. So now we will move further, we will carry out the further derivation. Now for further derivation, we have to write it as it is. This 1 plus cos square x will be remain as it is, and the function sin square x we have to derive, so the value or the derivative of sin square x is equal to 2 sin x, as we know, into the derivative of means n into x raised to n minus 1, which is my value of n is equal to 2. So 2 sin x into 2 raised to 2 minus 1 into the derivative of sin x. So derivative of sin x will be cos x. Okay, looping derivative or going inside, we can say. So it will be like this, and then minus sin square x will remain as it is in this case. So I am writing it here, so it will remain as it is, and the derivative of 1 plus cos square x will be 1 will be 0, and cos square x will be equal to sin x, cos square x will be equal to 2 cos x into the derivative of cos x. Derivative of cos x is equal to minus sin x. So here it is minus, here it is minus, so minus minus will get equal to plus, and in the whatever in the denominator we will write it as it is, because no need to change, no need to take the derivative, because as per the formula we have put the values, we have taken the derivatives, and we will simplify right now. So this is minus sign, so we will remove the minus sign, and here it is minus sign, so minus minus become equal to plus, minus into minus become equal to plus in this case, because the derivative of cos square x is equal to 2 cos x, and again we have to derivate the cos x. So the derivative of cos x is equal to minus sin x. So the combined derivative of cos square x is equal to minus 2 cos x into sin x. So that will be my derivative. So now we will solve it. So we have to multiply this bracket. So after multiplying, we will get the values of, we will, after multiplying the bracket, we will get the values of 2 cos x into sin x. So it will be 2 cos x sin x, uh, 2 cos x sin x into cos cube x plus cos cube x. So it will be cos raised to cube x, cos cube x into 2 means 2 cos cube x. 2 is common every time, so it will be 2 cos cube x into sin x. Then again plus, and again it is 2 sin cube x, sin cube x into cos x divided by this function. So one thing here, it is clear that we can take 2 sin x cos x as a common factor over here. So after taking 2 sin x cos x as a common, we will get the value equal to, so because see, uh, here it is 2 sin x cos x, here it is 2 cos x cos cube x sin x, here it is 2 cos sin cube x cos x. Is in three of the terms, in these three terms, we can, in the numerator, we can see that the sin x, cos x and 2 are common in the three terms. So we take this 2 sin x cos x as a common in this case, and we take it out of the bracket. So we got as 1, because we have taken from here 2 sin x cos x out or common. So we put 1 over here, 1 plus, sorry, 1 plus, then here it is 2 cos cube x. So 1 cos x I have taken common, and sin x I have taken common, and 2 I have taken common. So cos cube x will become cos square x. So it will be square cos square x, and here it is sin cube x. So here it will be sin square x. So it will be sin square of x, and in the denominator it will not change, it will remain as it is. So no need to change the denominator. Now again one thing we have to do here, that sin square x plus cos square x equal to 1. As we know that sin square theta plus cos square theta equal to 1, so we replace cos square x plus sin square x by 1. So now our answer is completed, and we can go to the final answer over here, as 4 means 1 plus 1 gives me 2, then it will become 4 sin x cos x. So it will be 4 sin x cos x, and divided by 1 plus cos square x the whole square, 1 plus cos square x the whole square. So this is our final answer. If we integrate this particular answer, we will get this uh, we will get this as an answer if we integrate. Remember one thing, if we differentiate, differentiation and integration are inverses of each other. If we differentiate a function, and then after finding differentiating a function, and we again integrate that particular function, so we will get the same function. Such that if we differentiate f of x, then we will get f dash of x, and after different integrating f dash of x, we will again get f of x. Here we again we can here uh, simplify this expression as sin x cos x. So we can also write it as 2 sin x, 2 into 2, 2 multiply by 2 sin x cos x divided by this function. The function in the denominator won't change, but the function in the numerator can change in this case, because the UV rule always depends upon a chain rule. Means a denominator function cannot change. We have to only square the denominator function, and UV rule can be used in most of the cases in solving the sums. So as we know the formula for 2 sin x into cos x, which is equal to sin 2x, so we will write it as 2 sin 2x divided by this. So this is the final answer which we got. This will be the final answer. We can also simplify. If you don't want to simplify, you can keep it as it is. You can keep in this form, never mind. But if you want to simplify, you can simplify and bring it in the simplest form. You can reduce the answer and bring it in the simplest form. So now we will solve the next sum, or the third sum. The third sum is sec of sec into the tan of square root of x. So first of all, rub all these things, and let us consider as, or let us take y equal to sec of tan of square root of x. So it will be y equal to sec of tan of square root of x. So my derivative, or dy by dx will be equal to d upon d of x of this particular function. Now this function is quite different. So we know that the derivative of sec theta, as I told you in the previous video, go to my previous videos, and or you can open any mathematical book, and you can see the derivative of sec theta is equal to sec theta into tan theta, or sec x is equal to sec x into tan x. Then the derivative of sec tan square root of x will be equal to sec of tan square root of x into tan of tan square root of x. And again we have to find the loop derivative. We have to find the derivative of tan of square root of x. So my dy by dx will be equal to d upon d of x of tan square root of x. So my tan square root of x, for that finding we have to find the derivative of tan theta or tan x. So this I have written in the beginning. I will write it as it is. So sec of tan square root of x into tan of tan square root of x into d upon d of x of tan square root of x. So my derivative of tan square root of x is equal to sec square of x. So it will be sec of square root of x. So it will be sec of square root of x square root of x. So it will be sec square of square root of x. So sec square of square root of x. So now again we have to find a derivative of square root of x. So for that you find d by d of x of square root of x. Now we know that the square root of derivative for square root of x is equal to 1 by 2 root of x, or 1 by 2 square root of x. As we know that square root of x is equal to x to the power of 1 by 2. So 1 by 2. So finding the derivative of this particular function, we have d upon d of x equal to n into x raised to n minus 1. So 1 by 2 into x raised to 1 by 2 minus 1 into the derivative of x. So which will be equal to 1 by 2 root of x. That x raised to minus half will go in the denominator and it will become negative. So my final answer of this question will be equal to sec x into tan x, this particular function, and so divided by, I can use divide operator over here, divided by 1 by 2 root x. So 1 by 2 square root of x. So this is my final answer of the given question. So in this way you have to solve the complicated derivatives of trigonometric functions. In the next video we are going to solve the derivative of exponential, logarithmic functions, etc. So for today I am taking a leave. So please, if you like my video, please share, subscribe and comment on my YouTube channel Making Maths Easy. For more videos related to the maths, please subscribe my channel Making Maths Easy. Thank you for watching.